In this video, we're going to look at coordinate systems. We're going to start by looking at a one-dimensional coordinate system so that we can build up to a two-dimensional rectangular coordinate system. So let's begin with the one-dimensional coordinate system. In a one-dimensional coordinate system, we use one number line. One-dimensional means a line. So if we were to look at that, it would look maybe something like this, going forever in both directions and containing all of the real numbers, okay? Decimals, negatives, fractions, square roots, different things like that. No, there are certain numbers that aren't on here, the non-real numbers or the complex numbers, such as the square root of a negative number. But that's beside the point. Let's focus on the coordinate system. So if you wanted to locate a point on this number line, for example, if I wanted to locate the number, let's say x equals 5, the reason I'm labeling this with a variable x is because this could be labeled then as an x-axis. Or if it were y equals 5, it could be labeled as a y-axis, this number line. And so I would just simply mark a spot on here where 5 is, and I would put a point. Okay. Of course, if 5 is here, then 6 is to the right of it, and 0 is to the left, and you kind of get an idea of where all the other numbers are. But in one number line, you represent a point such as this one, represented by one number. You need one number to locate a point on this one-dimensional coordinate system. So how do we look at two-dimensional coordinate systems then? And this is a rectangular coordinate system. I'll explain that in a moment. For two-dimensional coordinate system, you need two number lines. And they are going to be perpendicular. So the first one might be horizontal like the one we looked at before, and it goes forever in both directions. And the second one should be perpendicular to that, so it would have to be vertical. Okay? So we've got two number lines to make up this system. And 0 on both number lines is where the two number lines intersect. So 0 for the horizontal number line is here, and 0 for the vertical number line is also here. On the horizontal number line, the positive numbers are to the right and the negative numbers are to the left. And on the vertical number line, the positive numbers are up and the negative numbers are down, as you could imagine. Okay? And 0 is right in between. Now, this particular point where the two number lines intersect has a special name. It's called the origin. Okay? The origin. And now if I want to locate a point is basically a dot, okay? So let me make sure you understand that. A point is a dot. And if I want to locate a point in this coordinate system, I need two numbers. All right, so typically the horizontal number line, the horizontal axis is called the x-axis, and the vertical number line is typically called the y-axis. They don't have to be. They could be any axis that you want, but typically x and y. X is horizontal, y is vertical. So if I want to locate a point here, I need an x value and a y value. So I might say x equals 5 just like before, and the y value that goes with that would be maybe -2, for example. So if I want to locate that, I need to find 5 on the x-axis. Well, as we said before, positive numbers are to the right. So let's say 5 is here on the x-axis. Notice I'm not putting a point on 5. And then y is -2. So on the vertical axis, the y-axis, negative is down. So I go down 2 units, maybe here. And that point is located, sorry about that, right here. So a point in 2 dimensions represented by two numbers. Okay? Now, you can imagine this extends to 3 dimensions. You would use 3 numbers. In 4 dimensions, you would need 4 numbers, okay? But we're going to stop here at the 2-dimensional system. Now, since every point in a 2-dimensional system has to be represented with 2 numbers, it would be cumbersome to write this representation every time. So instead, we create a shortcut notation because all we really care about are the 5 and the -2. So what we do is we write 5, comma, -2. And we put parentheses around it. And that's the notation that we will use for points in 2 dimensions. This is called an ordered pair. It's called an ordered pair because x is always first and y is always second. So the order that you write these is important. And by following this convention, we don't have to write the letter x and the letter y. We can ignore those. I'm putting it here just so you understand this is x and this is y. But without those letters there, you know the first coordinate is the x and the second coordinate is the y. Okay, finally, the last thing is this 2-dimensional system makes up a plane, right? A flat surface that goes on forever in every direction. It's like a flat piece of paper, but it goes on forever in every direction. And you can imagine all the different points in this plane. This plane is cut into 4 regions. Here's one region. Here's another. Oops. Here's another. And finally, the last is down here. Goes on forever. It's cut into 4 regions. Those 4 regions are called quadrants. So this is quadrant 1. The reason this is quadrant 1 is because every point in this quadrant moves to the right and up. When you move to the right, that means your x is positive, and when you move up, your y is positive. This is the most used quadrant. The quadrants are usually labeled with Roman numerals, so quadrant 1, and every ordered pair has a positive x and a positive y. In lots of real-world graphs, we typically only deal with positive numbers, positive time, positive money, different things like that. So this is the most used quadrant. And then we proceed to rotate counterclockwise to label the rest of the quadrants. So this is quadrant 2, so shortcut is Q2. This is quadrant 3. And finally we have quadrant 4. In quadrant 2, you go left and up, so x is negative, y is positive. In quadrant 3, you go left and down, so x is negative, y is negative. And finally, in quadrant 4, you go right and down, so x is positive and y is negative. So we've got the origin, where x and y are both 0. We've got a point in 2 dimensions represented by an ordered pair. And we have the quadrants in 2 dimensions. Quadrant 1 is where both coordinates are positive, and then you rotate counterclockwise to get the other quadrants. And we have the x-axis, which is horizontal, and the y-axis, which is vertical. And that is the 2-dimensional rectangular coordinate system.